Hello guys and welcome. So first of all, a small caveat, if you don't know any of the theory or tools I'm going to be using in this video, then check out my YouTube channel because there I give full-on lectures on everything that I use in my videos. And now A, B and C are positive real numbers such that A times B plus B times C plus C times A is equal to 1. We're supposed to prove that S, which stands for sum, which is equal to A over the square root of A squared plus 1 plus B over the square root of B squared plus 1 plus C over the square root of C squared plus 1 is less than or equal to 3 over 2. Okay, so how are we supposed to approach this problem right there? Well, we have fractions and we have square roots, so maybe hold the inequality, maybe cautious choice inequality to eliminate those fractions and the square roots maybe at the same time. Well, those for sure would be nice if we were to prove a lower bound of this sum. The problem is that we're supposed to prove an upper bound, so I think they probably will not be of any use here. Yeah, that's not nice. So, maybe we should for now stick with what we got and try and work out some kind of way to simplify this entire sum to maybe in the future think of any like theorems or tools we can apply to it. Yeah. So how can we simplify this thing right there? Well, I'm thinking here, under those square roots, in those denominators, we have those plus 1s. So plus 1 here, plus 1 here, plus 1 here. And we also have this nice constraint that 1 is equal to A times B plus B times C plus C times A. So maybe we could somehow use this to rewrite those denominators some way, yeah? Actually, we can use it, yeah? You see, A squared plus 1, so first of all, I'm gonna look at what is inside of this square root, of this first square root right there, is actually going to be equal to, well, A squared, this I have to rewrite, write once again, plus A times B plus A times C plus C times B. And that, after, well, factoring everything out, is going to be equal to A plus B multiplied by A plus C. And so by the same reasoning, unless that plus is awful, the same reasoning right there, we can actually go on and say that B squared plus 1 is going to be equal to B plus A times B plus C, and C squared plus 1 is going to be actually equal to C plus A times C plus B. Yeah, that's awesome. So, well, we got something, that's for sure. So maybe we could, well, keep this one in mind and kind of rewrite this entire sum. Maybe it will simplify things a bit, yeah? So let me erase this stuff, and don't mind me erasing this stuff using my hand because, well, I got erasers here, I mean professional ones, but they are just soaking wet. I don't want to wet the board because I hate writing on a wet board, honestly. And so I will just stick with using my hand, though it's weird, yeah? So how can we write this one, bearing in mind what I just erased? Well, it's going to look something like this. A divided by the square root of A squared plus 1 will become A plus B multiplied by A plus C. Then we're going to have B all over the square root of where B squared plus 1 will become B plus A multiplied by B plus C. And then we will have one more fraction, so C will actually multiplied by the reciprocal of the fraction of the square root of C plus A times C plus B. And we're supposed to do what? Well, we're supposed to prove an upper bound of this, which is equal to 3 over 2. And that's a bell ringing. So, lovely. Well, you see, that's actually a nice thing here, because I see square roots and I see separable fractions, because now we can separate stuff which is, well, under this denominator, because, well, this is a square root of a product, so this is separable. And I see separable fractions, and I see square roots. What do I think next? I think AMGM inequality, because we're supposed to prove an upper bound this. Well, AMGM is perfect for, well, proving upper bounds for geometric means. So let's maybe think and try how can we get those three things into like so we want to make them look like something that is similar at least to a geometric mean. So how can we write this one? So for example, A over the square root of A plus B plus times A plus C we can write as a great square root of A squared all over a plus b multiplied by a plus c. That's for sure. That's nice. But now we can go on and separate the fraction which is inside of the square root, getting what? Getting a over a plus b multiplied by a over a plus c. And that's nice because that's actually the geometric, not I'm going to say arithmetic here, but that's geometric mean of a over a plus b and a over a plus c. And so we can set an upper bound on this, and the upper bound is going to be what? Is going to be a over a plus b plus a over a plus c all over 2, which is the arithmetic mean of those two terms. And we can actually go and do the same thing for all of the terms in our sum. And so let me get a little bit more space to write this. And so what we got is, first of all, a over the square root of a plus b times a plus c is less than or equal to a over a plus b plus a over a plus c all over 2. Yeah, we can now by the same reasoning say that b over the square root of b plus a multiplied by b plus c is going to be less than or equal to b over b plus a plus b over b plus c all over 2. And by the same reasoning, c over the square root of c plus a and c plus b is going to be less than or equal to c over c plus a plus c over c plus b all over 2. And so what can we do right now with all of this stuff? Well, we can sum it up. And why do I want to sum this stuff up? Well, you see, when I sum all of the left hand sides, what I'm going to get is, well, the sum. Yeah? And so we will have s on the left hand side. Is what is the right hand side going to be? What is the upper bound on s? Well, let me actually grab a handful of colorful chalks, so maybe orange, red, and green. Lovely. So, actually, those fractions are gonna kind of group into pairs, which is nice. So c over c plus b, and for example b over b plus c. Well, those two for sure are gonna add up to 1 because well, those are gonna add up to b plus c over b plus c. Awesome. On the other hand, c over c plus a and a over c plus a, well, those two are also gonna add up to 1. Just as well as b over b plus a and a over a plus b. That's awesome because those two are going to add up to 1, those two as well, and those two for sure too. And so what the entire fraction is going to actually add up to is, well, those are going to add up to 3, but we divide everything by 2, so it's going to add up to 3 over 2, which, ladies and gentlemen, is the upper bound we are supposed to prove. And that was a dramatic effect, I know. Yeah, and so the problem is solved and it is proved. Yeah, got it. That was a shot for at least 3 points. Yeah. Okay, so thank you guys for watching and see you in the next one.